All right, seventh grade, here we go. Getting into scientific notation. A number is written in scientific notation when three things. And I'm going to pause. I'm not going to pause. I'm going to ask you to pause and write this down. A number is written in scientific notation when, and there's three things. First of all, it has to be written as a product, which means it's a multiplication problem. It's a product of a factor, and that factor has to be at least 1, but less than 10. So it can be 1, but it can't be 10. And it has to be written as a power of 10 with an integer exponent. So scientific notation is all about base 10 multiplication, okay? Putting things in scientific notation. We'll be talking about adding scientific notation, dividing, subtracting, multiplying scientific notation. We'll be talking about all of that. But what our keys today is, first of all, making sure we understand what scientific notation is. It's written as a product, which means it's a multiplication problem. The first number in the multiplication problem, the factor, is at least 1, but less than 10. The power of 10 has an integer exponent. Might be a positive exponent, might be a negative exponent. Okay? So if you haven't written this part down yet, then I'm going to put right inside there. If you have not written down everything inside there, please pause the video and do that now. All right, now, the first part of your assignment is simply going to give you a multiplication problem similar to these 4 that I have written here. And it's going to ask you simply yes or no, is it written in scientific notation? It's going to ask you to explain. I don't need you to explain. Yes or no will be good enough because that shows that we understand this here. Okay? So, the first one, we have 46 times 10 to the power of negative 8. Well, I see it's a multiplication problem. I see it's a base 10 with integer exponent. But my number here is 46. And remember, my factor number has to be at least 1, but less than 10. 46 is bigger than 10. So that first one is a no. I go to this one, 8 times 10 to the power of 9. Once again, I have my base 10 exponent. And this is 8, which is at least 1, but it's less than 10. So this one is definitely a yes. I look at this one, 2.7 times 10 to the power of 15. Well, I have my base 10 exponent. It's a multiplication problem. I have 2.7. 2.7 is bigger than 1. It is at least 1, but it is also less than 10. So this third example here is also a yes. Our last one, 37 hundredths, or 0.37 times 10 to the power of 8. I have my base 10 exponent, 0.37, but 0.37 is less than 1. This would be like 0.37 with no number there. This is less than 1. It can't be that way. So no, that is not written in scientific notation. Now, the second part, problems 15 through 23, give you problems that already are in scientific notation. These are all in scientific notation. Every number in that problem is already in scientific notation. So this section is not a yes or a no as to whether or not it's in scientific notation. Your job is actually to figure out what the answer is, okay? Now this is one of those where I don't really just want you plugging them into your calculator because you might get some very weird numbers and it might read errors. Sometimes it's going to work. But I really want you just to get to think about what's really happening here with base 10 exponents. You shouldn't already know as a 7th grader, we've talked about it before, whenever we're multiplying and dividing with base 10 exponents, all we're doing is moving the decimal. Okay, either left or right. Now, this is 4 times 10 to the power of 8. So the first thing I'm going to think about is, well, 4 times 1. And I know that's 4. Okay? Now, if I put a decimal in 4, it's going to go right there. All this 8 tells me to do is how to move the decimal. And it's telling me that I'm going to move it 8 places to the right. It's a positive exponent, so my number is getting exponentially bigger, which means my decimal is going to move to the right. 8 places to the right from where that 4 is, which means if I move that decimal 8 places, I'm going to end up with 8 empty spaces. Those empty spaces are going to have to be filled with zeros. So 8 zeros, 3, 4, 5, 6, 7, 8. Get my commas in the right place. 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3. I get 400 million. 5.27 times 10 to the power of negative 6. Well, first I can think about 5.27 times 1. Well, or I can just think of it as 527 times 1, which means my answer is going to have a 527 in it somewhere. All right? But now it's a negative 6, which means I'm moving the decimal, okay, 6 places to the left. So if I take this decimal and that's already there and move it 6 places to the left, 1, 2, 3, 4, 5, 6, my decimal is now there. And all of these empty spaces are going to have to be filled with zeros, which means I'm going to end up with decimal 0.0000527. And that's what I'm going to need to write down. It's going to be decimal, then I'm going to have those 5 zeros, and then 527. So if we move on to the next one, 3.2 times 10 to the power of 5. All right, well, I know that 32, if I think about the 32 times 1 is going to be 32. So my answer is going to start with a 32. All right, I'll kind of circle that there to show that that's our answer. Now this is 10 to the power of 5, so my decimal is going to be moving to the right 5 places. It's getting exponentially bigger. So if I want to rewrite the 3.2, I'm going to go 1, 2, 3, 4, 5. My decimal is now going to be there. I now have all these empty spaces that I'm going to fill in with zeros. So I end up with 32 plus 4 zeros. And I put those 4 zeros in there. I count backwards, 1, 2, 3. Put my comma in there. I end up with 320,000. Last one here. 9 and 875 thousandths times 10 to the power of negative 4. Well, once again, this is a negative 4, so I know my decimal is going to be moving left. So if I come over here with my 9.875, and I take my decimal, and I'm going to move it 4 places to the left because my exponent is negative 4. 1, 2, 3, 4. My decimal is there. I now have these extra spots, 3 of them in fact, where a 0 needs to go. So I end up with decimal 0.0009875. All right, make sure your decimals are in the right place. Remember, negative exponents, you're moving the decimal to the left. Positive exponents, you're moving the decimal to the right. All right, have a good day, 7th grade. Bye.